All right, as I mentioned last time, we've got a folder now so that if you see a mistake in your grade, just upload a note here, and they'll take care of the mistake in your grades. Yeah, you can text me as well, but that way you get something and you'll see some feedback posted right there saying that I've corrected it. It's kind of a more traceable mechanism. But you could always tell me about a grade mistake in any other way as well. It's just that this ensures that'll happen. I had some questions in the other class about people taking exams or tests and then saying that it wasn't saving their grades or it wasn't grading them or something like that. And that's because of a misnomer in terminology probably. People were going in and finding the tests within MindTap, which is great, except since I used the word quiz, they took the quiz rather than the test. You got to take the thing that's called test. So right here and now, we're going to see if, I don't see a bulk edit here. We're just going to change the name of these to, instead of quiz reminder, test reminder. Or what are they called? Exams. Let's find out. So like if you hadn't done the first one yet, you could go to our quiz page in D2L, click on the link, it'd pop you over into MindTap, Engage, and you would like to have actually started the exam. It did not. Okay, well they're calling it tests. Not sure why it didn't kick into the test there. Hopefully it does for you. Look for the ones that are called tests. Those are the ones that we need to take. And access them through D2L. That's the fastest way to find them. And certainly you don't need to have finished like the second exam, the second test, when we're not even done with Chapter 1, although we will be. So let me change the due date on this to next week. Looks like it's already set for next week. And these are just reminders anyways. I've said that before. And speaking of finishing a chapter that we've been on for too long, we're going to go ahead and finish off Chapter 1 today, start on Chapter 2. Now the reason it's taken us so long to get through Chapter 1 is I've taught a lot more than is actually officially in the chapter, which means some of the later chapters will go through that much more quickly. We've already covered some of the material in them. Doesn't mean we're going to skip it in the later chapters, it just means that I like to show you stuff and then you see it in the book and on the PowerPoints. And then you see it again in lecture, and the third time it totally clicks. So we talked about sentinel values, right? We're entering a series of scores, and a specific score means exit out of the data entry mode, right? Nobody is meeting my eye. Yep, one person met my eye. Awesome, awesome. Okay. Sentinel value, which is a special value that indicates the end of a series of data. Example, in your score or -1 to quit, something like that. I want to revise the example that we gave for sentinel value. Last time we had it where you typed in -1, but I don't think we made it where you could type in the letter Q to get it to stop. Yes, sir?
Are you recording?
Yes, I am, and thank you so much for asking. Absolutely am. Okay, so here's what our example is going to be. Same kind of thing. It's just going to say add a number. Or maybe we're writing a number guessing game. right? I'm thinking of a number between 1 and 10. But we want to let them get out of the game, right? But anyways, we're just going to ask them for a number. That's all that this code is going to do. But if they type Q, it's going to quit. So here's what we're going to do. I'm going to do number equals input, parentheses, quote, enter a number, or Q to quit. End quote, in parentheses. Then on the next line, while number, and I'm going to say the word's not equal, but that's not what we're typing. Exclamation mark equal. Exclamation mark equal. While number is not equal to, quote, Q, end quote, colon, print. Yes, that's a number. End quote, in parentheses. Now let's ask them for a new one. Except we did not convert it to a float or something like that. So let's go ahead and convert it to a float so that we could have done some math with it. So before that print, yes, that's a number. We're going to convert it to a float. Number equals float, parentheses, number, in parentheses. And then we're just going to ask them the same question again, where it says input, enter a number. I'm just going to copy that and I'm going to paste it inside the while loop. And then print, parentheses, quote, wow, that was fun. End parentheses, end quote, end parentheses. Sorry for covering up the code. I believe this is Lecture F. Here we go. Now this is silly because we're not doing anything with the number, but we could be adding the number, we could be, validating it, we could be looking up somebody's user ID based on it, whatever, right? This is just showing the idea of using a Sentinel value. In this case, our Sentinel value is Q rather than a digit. And the reason we're able to get away with that is that we are waiting to do the conversion to a number until after we've already checked to make sure it's not a Q. Right? Because if we did this line, number is equal to float number, up here above the while statement, but they typed in a Q, well, a Q can't be converted into a number. So instead, we put it inside the loop. And the loop is going to keep repeating until they give us a number that is equal to Q, until they type in Q, until our user input equals Q. And this is kind of like an if statement. If this condition is false, it doesn't go back into it, right? So it keeps repeating these statements only while this condition is true, while it is not equal to Q. As long as it's true, it converts it to a number, it asks for a new one. And enter a number or Q to quit. Okay, 4. Yep, that's a number. 5, 6, Q. Wow, that was fun. Okay. Let's go ahead and make it so that we are actually adding that number. We're adding the numbers up. So I'm going to create a variable called total, and I'm going to set it to 0. This is called our accumulator variable because we're accumulating values into it, right? Accumulating just means growing. It's gathering the data. So total is equal to 0. I just added this line. You don't have to add those hashes. Those are there just to draw your eye to it. And I'm going to add another line here. I'm going to wind up deleting or changing that print statement. So this one, we need to add 1 to total. Excuse me, we need to add the number to the total. There's 2 ways to do that. You could do this, total equals total plus number. Or you could do total plus equals number. Both of those work. And then that silly message, yes, that's a number. We're going to make that print the total instead. So I'm deleting that line, and I'm going to make it say print, parentheses, quote, total is, end quote, comma, total, T-O-T-A-L, end parentheses. And so that's one more line that I've changed, so I'm going to mark it with a couple of hashes too. Don't do those. Those are just to draw your eye to my changes. Just make sure it works. Whoops. It doesn't work if you don't enter any data. I hit enter, and so it crashed. That's not good. Right, it's printing out our total. Now we're going to queue. All right. Okay, so that probably makes, anywhere between 25 to 100% sense in your mind. So we're going to just write one more simple loop. We're going to write a countdown like we're launching spaceship 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So I'm going to do count. This is our countdown. Is equal to 10. And then we're going to have a while statement. While that counter is greater than 0, or greater than or equal to 1. Let's do it that way. So while count greater equal 1, colon, while it's greater than or equal to 1, we're going to print that number. So my next line is going to be print, parentheses, count, comma, quote, dot, 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 just so it looks kind of like, pausing. Nah, I'm going to get rid of dot, dot, dot. That's going to be silly. Let's get rid of that. So print, parentheses, count, end, parentheses, and let's remove one from count. It's called decrementing. Count minus equals 1. Dash equals, or you could say count equals count minus 1. It means the same thing. Count equals count minus 1. And then we're going to print a message. We have liftoff. Once it's done. Just checking it to make sure it works. I'll bring the code back in just a second. Okay. I'm going to put a comment here as to what this is. This one is demonstrating a loop that counts down from 10 to 1. That's what that is. And this upper one, the first one we did is demonstrating a data input loop with a sentinel value of Q. Right, Q is our sentinel value. It's what kicks us out of it. That's not the only way to do data entry, though, right? We could just ask them every time, right? Enter a number, they type in 10. And then we say, do you wish to continue? And they type in yes. Enter a number, they type in 20. Do you wish to continue? Yes. Enter a number, 5. Do you wish to continue? No. And then it bails out, right? But they're having to answer 2 questions for every piece of data that they type in, right? They had to type in first the number, and then the why to continue, or the yes to continue. Doing a sentinel value lets them do it just in one, a series of one piece of data at a time. 10, 25, and then Q to bail out, or -1 to bail out. Okay, so let's go ahead and flowchart these 2 bits of code, and then we're going to hit chapter 2. So I'm going to go back into Lucidchart, lucidchart.com. It's forgotten who I am. Log in. Really? All right. J.G. Thompson at rader.rose.edu. So on Monday we said that every flowchart begins with what kind of shape?
Oval.
Yeah, an oval. Let's drag an oval out there. Now I'd kind of like to have the code for that available to me to look at. So I'm just going to come over here. It's kind of long, I don't know. Maybe I'll just knock it over to the side. Wait, we've already established that that does not just really work well in this editor. And we'll give it a shot. Okay, so the first thing in our code was number equals input. And here's where we get into a distinction or a difference between, if you write the code first and then you flowchart it, you start wondering how complicated you should have made it, right? As a matter of fact, I'm going to skip this section entirely. I apologize for that, but I did not think ahead about what this was going to look like. And here's my beef with how I did it, is that I did both the print statement and the input statement in one statement here, but on the flowchart we usually separated them, right? We had a print and then we had an input. And then we have this conversion here, and we weren't putting conversions in our flowchart at all. So I'm skipping that, and we're just going to do the loop. We're just going to do this one. So I am going to copy that code. I'm going to take this code here, copy those lines of code. Maybe I'll get rid of the comment when I paste it. I need a box to hold that code, so I'm just going to grab the T or this white box and pull it out. I'm going to paste it. And I want it to be left justified. So I need to highlight all of that. Go to the alignment thing. And we don't want it to be center aligned. We want it to be left aligned.
How do you do that?
So what I did is I copied it from idle. And then I went over here and I grabbed the white box and I pasted it. And then since it wasn't centered correctly, I went up to this. Where is it? Where is it? Right there.
Then you click the...
I clicked that and I clicked center to the left. That one. That makes sense? All right, cool. All right, so we need to set a counter. That's a form of math. It's not a decision, which is a diamond. It's not a form of input or output. It's just an assignment. So we're going to do count equals 10, or we could do set count equals to 10 if we wanted to make it look like pseudocode. Usually you don't draw your flowchart from finished code. It's kind of going backwards, right? It's kind of like building a house and then writing a blueprint for it. But, you know, I guess if you lost your blueprint and you need to recreate it, you can do that. So now we have a while. A while is done in the same shape as an if. It's a decision. So I'm going to come over and do a decision block that says while count greater than equal 1. Something's bugging me a lot about this. All right, there we go. While count greater than or equal to 1. Well, if it is, if the code's indented, we're going to come over here and we're going to print count, or we're going to output count. Don't care which word you use. print, make it match our code. And then the next line is definitely math. So it's not going to go into tilted. It's just a process. So then we're going to remove 1 from count. Count minus equals 1. Or if we thought it was prettier, count equals count minus 1. And that's the end of the loop. So to indicate that it's the end of the loop, we need a line going back from this code back up to the while. Now loops are the only time you draw an arrow from a later stage in the chart to an earlier stage. Where you make that arrow hook up to the diamond is your choice. I just ask that you don't put it there, because that's where we're going to put the line that leaves the while loop. So I kind of like to try to snuggle it up like that, make it hit the diagonal of it. But that's not the only way. You could do it like this. Some people like doing this. That's more how the textbook shows it, I believe. Actually, the textbook shows us something almost completely different. So that works. I usually try to make it hit the diagonal, but you know, that's just for prettiness sake. Doesn't matter. If you think it's prettier for it to go into it like this, that's totally cool. And now we're done. We've exited the while loop, so we're going to drop down and print we have liftoff. That's another print statement. So that's a data block, a tilted rectangle. Print, quote, we have liftoff, exclamation mark, end quote. I can't get my line to line up, and it's annoying me, and I'm wasting time doing so. But to fix it, I'm zooming way in so I can grab the point and move it the way I want it. All right, and then lastly, we just need a stop. We had a start, so we have to put a stop. Wish there was a happy medium between these two sizes. Well, I guess that's it. I guess that gets most of it on the screen. So that's a while loop. If you look in the book, it's going to look a bit different. The book's not going to put the word while there. I've already mentioned I like putting if in my diamonds, if that's what it's doing. And I like putting whiles in my diamonds while that's what it's doing. Why? Because I think it's easier to make a program from this if I'm looking at it and I don't have to guess. So, well, is that an if statement or a while statement or a for statement? If it's got the word there, then we know what it's doing. So why not? That's just a little bit of extra information that is useful. But the book would not have that. And I'm going to hit Control Enter there to put that condition on the next line. This is known as the condition.
Control what?
Control Enter embeds a character term. Like that. It's how you get a line break while you're typing in a block. Like that. This is known as the condition. And as long as this condition is true, if this is true, yes, come and print the count, remove 1 from the counter, and go back up and check again. So the count starts off at 10. It's going to print 10. It's going to subtract 1 from it. It's 9. It's going to come back over here. Is 9 greater than or equal to 1? Yes. Print it out, remove 1 from it. It's 8. Is 8 greater than or equal to 1? Yes. Now I'm not going to sit here and wave my hand 7 more times. It finally gets to the point where while count is equal to 1, we're coming back here. Count is equal to 1. Is count greater than or equal to 1? Yeah, because 1 is greater than or equal to 1. We print it out. We subtract 1 from it. Count is now 0. It comes over here. Is count greater than or equal to 1? No, it's 0. So it falls through. It exits the loop. We print, we have liftoff and it stops. So this is the expression in flowchart of that code. We will certainly hit loops again, so it's not like I'm going to tell you to go home and write a bunch of loops tonight as homework. We may flowchart something, so I'm not going to save and close this yet. Well, we may as well save it. File, save, Lecture F. I see people taking advantage of elite strategies, drawing, like making this line a curve rather than a straight line. I mentioned how to do that. You just go to this line options, and you can choose to make it a curve, but then you have to set it to how you want it to look. You know, you can spend a lot of time making these things look special. Right, I'm going to undo those changes. There we go. All right, back to our lecture. The text editor is used to create a simple text file. Well, that's what idle is. It's a text editor, but it's a little bit more because it's got the run menu in it, and it's got the shell, and so it's really more of an IDE. It's a pretty primitive IDE compared to some visuals IDEs, which stands for Integrated Development Environment. I'm just going to launch Visual Studio and let you see what a top-of-the-line skyscraper monolith 1,000-pound gorilla of an IDE looks like. And it's taken forever, but you can already, come on. Well, for an example that was only supposed to take, 10 seconds to do, it's taken 45 to load all of its components. So what does IDE stand for? Integrated Development Environment, meaning that you have a place to enter your code. Now, usually in an IDE, you create what are known as projects. An IDE doesn't do this. You create a project and then you add files to your project. And I'm not going to bother getting it to work from what it was just doing. So forget that. The command line is your location on the computer screen where you can type text entries to communicate with the computer's operating system. On Windows, you can launch the command prompt really quickly by, you know how there's a Windows key between the Alt and the Control key? Sometimes there's a little FN function key too, but if you hold that Windows key and then R for run, Windows R, it gets that little box, that run box, and you can type in CMD and hit enter. Now that's a command prompt. You Mac users aren't going to get it that way. You Mac users need to launch what's known as the terminal. If you know how to do that, great. If you don't, you can always go up to the question mark in the Mac, toolbar up at the top. Not a question mark. It's a magnifying glass. Click the magnifying glass, type in terminal, hit enter. You ought to be able to find it. Now, I'm not going to actually spend hardly any time in this except to show you that this is, in fact, a command prompt. You can type commands there. On a Mac, you would type ls. On Linux, you would type ls. On a PC, you type dir. And you get a list of, all the directories in there. Now, so let's say that I'm looking for every Python file that is inside my directory. I don't remember the same command on a Mac, but I'll show it to you on the PC. Let me blow up the font size of this just a little bit. Okay, so dir/s *# Now it's got a lot to search, but it found them. It found all my files, and it said that they were all in a directory called C users JG Thompson desktop CIT1113. Well, that's just where mine happen to be. You may be saving yours to a flash drive. They may not be on the C drive at all. If I want to get a more succinct, a briefer version of that output, I'm going to type in the same thing, dir *.py/s, which means search for subdirectories, and then /b for brief. And there. Then it's giving it to me in a very succinct form, right? If I wanted to run one of those applications from the command prompt, I could do that as long as Python is configured to run from the command prompt. And how can we tell if it is? We can type in Python and hit enter. And if it does that, we're good to go. That's about enough of that. You've seen a command prompt now. And if you're a system administrator or you know, it's very possible that you're way skilled in that. You've done a lot of it. It's also very possible that you've hardly ever done it. Our particular command prompt that we use more often than this one is the shell, right, from within idle. And even then, what we usually do is we just create our application and run it. While you have a command prompt, a command line for running these kind of programs, it's more cool to write a program that's got windows, you know, and menus and buttons and stuff like that. And that's called a graphical user interface. And hopefully towards the end of the class we'll be doing some of those as well. But that's almost out of the purview of this book, which is teaching programming logic, and writing graphical user interfaces is not part of logic. It's what you'll do if you take scripting, CIT1213. So for example, a command prompt version, a command line version. Please enter a number 13. 13 doubled is 26. Here's the graphical user interface version. Please enter a number 13. 13 doubled is 26. Yeah, right, like that looks cooler. We'd like to know how to do that, so we'll do at least one like that. I'm going to totally skip the next couple of slides, and we're going to go to chapter 2. Elements of high-quality programs. All right. In this chapter, you will learn about declaring and using variables and constants. Well, we've been using variables the whole time. Performing arithmetic. We've been doing arithmetic. The advantages of modularization. Okay, there's a new topic. So variables consist of, and I'm having deja vu, but on the other hand, I teach, 6 different languages at 6 different levels of difficulty. Variables we could give it a fancy definition, and I'm not going to give it a fancy definition that might differ from what the book has you memorize. So I'm just going to say variables have 4 components. They have a name. Is this sounding familiar if I typed this already? Yep, I see at least one head nodding. They have a type, they have a value, and they have a memory address, which we do not care about. The type controls what kind of data it stores and what can be done with it. What operations. For example, ints and floats, you can do math on it. So you can do plus, minus, addition, subtraction, power of, floor division. Strings, you can add 2 strings together with a plus sign, but all that does is concatenate them. So, ints and floats, you can do plus, minus, multiplication, division, power of, and floor division. Whereas strings, you can use plus, but it just adds two things together. And you can do star, but it just repeats it, right? And so the plus does concatenation, which is appending. And the star does repeat, not repat. So if you have a piece of data that's stored as a string and you try to do a division on it or raise it to the power of something or use a minus, you're going to get an error. And when you're doing these things, the data has to be of the same type. If I have a string and I want to add another string to it to concatenate the two together, they better both be strings. I can't say hello plus 3. I'm not going to add 3 to the word hello. They would have to be of the same type. They would need to both be strings. On the other hand, if you're doing math, again, they have to both be of the same type. They have to both be numbers, right? So, if you're going to do a division, you better not try to divide an int by a string. You better divide an int by a float or an int by an int. So numeric consists of numbers that can be used in math, and a string is anything not used in math. Okay, that's a little overly broad, but we know what numeric data is. And then the strings are the text data that you can enter from the keyboard. Names and addresses and stuff like that. The reason I would complain about this, a string is anything not used in math. Well, my selfie is data, but it's not math, and I wouldn't store it in a string. It's something completely different. That turtle that we played with one day is not math, and I would not store it in a string. So constants. There are two kinds of constants. What is a constant? A constant is a value that's not supposed to change. The variable can change, right? V is equal to 1. Then maybe later I'm going to add 2 to V and it's going to become 3. Its variable varies while the program is running. A constant is not supposed to change. But there are two kinds of constants. If we go to our source code, we see one here. That's known as a literal, or an unnamed constant. It doesn't have a name, but if you were going to edit it, you would literally have to open the source code and change it right then and there. So it's an unnamed constant. So constants are values that do not change while the program is running. And there are two kinds. There are unnamed constants, which are also known as literals. Things like 10, hello, 3.14159, whatever, all of those numbers and those strings that we typed into the source code, that's literally embedded in the source code, those are literals. Those are unnamed constants. I keep using the word literally because somebody invented the word literal for this data type, and I never quite figured out historically where that came from. But if you had this program here, if you had my countdown program and you decided that our rocket needed to launch a lot more quickly and you wanted to start counting at 5, to change it, you would literally have to come in and change that 10 to a 5. Then there are named constants. Named constants are variables that you create to hold a constant value. That sounds like a contradiction in terms, right? It's a constant variable. Well, that's exactly what it is. It's stored in a variable, but it's a constant. So a named constant is a variable that contains a constant value. Now, our language does not support named constants. All it supports are literals and variables. So we indicate that a variable is supposed to be constant by giving it an uppercase name. We indicate that a variable is constant with an uppercase name. So something like max underscore students equals 30, right? speed underscore of underscore light. I never remember this measurement. Speed of light, meters per second. 3.0 10 to the 8th. All right. So 3.0 e to the 8th. Right. And then when I'm writing my code underneath it, or somebody else comes in and they see my code, and I'm doing things like this, you know, if x is greater than max underscore students. You know, even if they didn't see anything else in the code, they would know, because I typed that variable name in all uppercase letters, that it's supposed to be a constant. And even if my language doesn't prevent me from changing it, which Python doesn't, I'm not supposed to change its value, right? It was declared once, it's supposed to stay that way. And if it needs to be changed, it needs to be changed up at the top of the program where it is declared. It needs to be given a different starting value. And it's never supposed to change once given a starting value. So there are numeric constants, numbers, 0, 1, 3.14, 159. There are string constants, like the word hello, you know, that we've been putting into our code. Or this is a string constant, right? We have liftoff. If I wanted to change that message, I would have to open the code and change it. The user doesn't type in that message. Not a variable, it's a constant. But it's an unnamed constant. It's a literal. It's literally embedded in the code. What I could do is I could store it in a variable if I wanted to. I could do something like this. Message equals, we have liftoff. And then I could print that message out. But there, now we've stored that constant in a variable. And if we ever wanted to change it, we could, right? We could change our message. Like, we're amazed that we have liftoff, so we're going to put a bunch of question marks after it. Whatever. So working with variables. Variables are named memory locations whose contents can vary or differ over time. The declaration is a statement that provides a variable's data type, its identifier, and optionally an initial value. Now that's all true, but in our language it's slightly different. The declaration does not specify a data type. It does give a name, and it has to give an initial value. But different languages are different. I'll show you what I mean. If I come in here and I was programming in something like Java or C, and I wanted to declare a variable, just a sec, a variable called x and give it a value, I could do it like that, and then I could give it a value like that. That's C or Java. Our language doesn't have that option. In Python, the syntax is so much easier. We just do this. X is equal to 1, and boom, we're done with it. This is called declaring it or defining it. This is called assigning it. When you declare or define a variable, you're dictating a data type. You're saying this is an integer, that's all that it can hold. All that it can hold are ints. We can't store a string into it. But Python is a different beast. It's written to have a simpler syntax. You don't declare your variables and give them a type. Instead, it picks the data type based on the data you're storing in it. I'm putting a 1 in there. Oh, okay, now I'm an int. Yes? So hand raised? On the community text that we're looking at? Yeah, I'm sorry, guys. It's not that you're blind, it's that you're sitting 200 feet away. Don't have much of a choice in that, so let's... That better? Yes. Slightly more legible, hopefully. Okay. So when the book says that's a statement that provides a variable's data type, identifier, and optionally an initial value, we have to give an initial value in Python. And based on that initial value, Python picks the data type. So in C or Java, if I was declaring a string, I might have to do this. String name, name equals Joe. Here, down in Python, I do name equals quote Joe, and we're good to go. We did not have to pick a data type. It picked up its data type based on the data that we're shoving in it. So I'm going to go ahead and copy what they said there, but I'm going to amend it. Declaring a variable, you give the variable a name, a type, and optionally a value. And then I'm going to put our caveat. But in Python, you must specify a type. Excuse me, you must specify a value, and the type is determined from that. You must specify a value, and the type is determined from that. Just like this. X equals 1. 1 is an int, so it turned X into an int. Joe is a string, so it turned name into a string. In these other languages, once a variable is declared, you can't change its type, right? I can't then turn around and store the word hello into the X variable because it's configured to only hold numbers. If I did X is equal to hello in Python, it doesn't care. It doesn't care that 2 minutes ago it was an int and now we're trying to use it as a string. It's okay, it'll do that. It operates by more loosey-goosey, flexible rules, which can be a blessing or it can be a hindrance. It's what's known as a loosely typed language. Loosely typed meaning that you can store any kind of data into any variable. A strictly typed language is one where once a variable is defined, it can only hold data of that type. So in C or Java, once you declare the name was Joe, you couldn't turn around and stick numbers in it or images or, turtles or anything like that. Quite often, at the top of your program, you do a bunch of declarations. I'm going to write a program that, calculates this, that, or the other. So. So we're going to write a program that will calculate something known as the body mass index. The body mass index is where you take something's weight and something's height, and it does a division, but not just a straight division, and it calculates a body mass index. And people use it to track, weight changes over time, or check to see if something is out of the ordinary range for a specific population or whatever. So I'm going to go in and I'm going to write some pseudocode for doing that. Pseudocode for body mass index calculation. Now to do this calculation, we have to have 2 bits of information. We have to know somebody's weight and somebody's height. And depending on whether you're doing it in metric or English units, you either need to know centimeters and kilograms or pounds and inches. So we're going to do it in English, because that's what most of us speak. So we're going to declare our variables. We're going to, whoopsie, where'd my PowerPoint go? These are known as declarations. A declaration block is when you have a bunch of variables defined up at the top of your code that you know you're going to need pretty soon. So, declarations. Height equals 0, or set height equals 0, or maybe I'm going to say set inches, right, because that's what the unit is. And set pounds equal to 0, and set BMI. The only reason I'm putting it in caps is because it's an abbreviation. Maybe I'll do lowercase. BMI equals 0. Now this is more formal than we would normally do it in Python. In Python, you do not have to declare your variables before you use them in input statements. But in most languages you do, and that's what the textbook is showing, and so I'm giving you a demonstration of it. All right, so now we need to input inches. So input inches, input pounds, and now we're going to do a calculation. Set BMI equal to, let's see if I remember the equation, 700, and not that it really matters, huh? 703 times pounds divided by inches to the power of 2, inches squared. Inches star 2. That's our formula. And then we would output BMI. And then our program is done, so I'm going to type in stop down here.
Do we put start at the top?
Yeah, we have start here, and then we have a declarations block underneath that. Yep. Now, when we turn this into code, it's going to look a little bit different. Remember how just because we have a tab here after the word start in pseudocode, that doesn't mean that all of our code is tabbed. Similarly, we don't extra tab our declarations just because that's what pseudocode wants us to do. I'm just going to go ahead and end my comments here so that we can actually code this. So I like that word start, so why not type it in as a comment? I like that word declaration, so why not type it in as a comment? And then what were our declarations? Inches equals 0, pounds equals 0, BMI equals 0. You see what I'm saying? Just because the pseudocode had this stuff indented, we didn't indent it in our code, because our language is very specific about the fact that you only indent after a colon. You don't see any colons in our logic yet, so we're not indenting anywhere. All right, now we need to do our input of these two things. And remember, whenever you do input, you're actually doing three things if it's a number. You've got to tell them what to input. You have to convert it, right? So let's ask them for the inches. Inches equals input, parentheses, quote, how tall in inches, question mark. Or we could just shorten it to inches, question mark, right? End, quote, end parentheses. And the output will look a little bit better if I put a space after the question mark. So I'm going to just add a space there. But it's not a number yet. As I keep saying, we would have to do some math on it, on this to actually get it to work. So we need to do some conversion to get it to be a number. Float, inches equals float, parentheses, inches, end parentheses. So next, we have the inches, but we need the pounds. So pounds equals input, parentheses, quote, how many pounds, question mark. space end quote parentheses. And then again, we have to convert that. Pounds equals float pounds. I'm going to scroll up for a second. So far, we have taken care of everything from here to here with these statements. The pseudocode actually looks like more elegant and formalized and prettier and stuff. But that's because in pseudocode you're not doing the heavy lifting of actually having to tell it how to do it. All right, so now we're going to do our calculation. Okay, so if these are our declarations, then what's this stuff? I'm going to put a comment here saying that this is get input. And then I'm going to add another comment that says perform calculations, right? Or calculate BMI. And so the equation is BMI. Remember, there's no set keyword. That's just for pseudocode. BMI equals pounds divided, pounds times 703. Let me just go and copy it from here. Yeah, okay, fine. 703 times pounds divided by inches power 2. Then we would want to print that out. And then, so display results, or show output.
So it has to be 703 times pounds? Or
Are you asking if I've typed it correctly?
I'm asking, first you type pounds times 703.
It would work either way, correct, right. Either way works because,
Well, if you did it that way, then it doesn't matter?
right, because multiplication, it doesn't matter whether you're doing 2
Okay.
times 3 or 3 times 2. Yeah, good question. And then print, parentheses, quote, calculated BMI is or equals, end quote, comma, BMI. And then how about a stop comment to wrap things up? Now, in this particular language, we could have done away with this entire block. We did not need these 3 lines at all. Why? Because in this language, to create a variable, you just put a value in it. We didn't have to pre-declare it up ahead of time. So inches equals 0, we didn't need it because we're putting a value in there. Pounds equals 0, we didn't need that. BMI is equal to 0, we didn't need that. So this section was useless for us, but the book's going to demonstrate it, and in other programming languages, it would not be unnecessary. Q to quit. How tall in inches. Well, this is annoying that it's off the screen and you can't see it. All right. I don't know what that 0 is doing there. I'm going to say that I'm 70 inches tall, and then I weigh 300 pounds, and so I have a BMI of 43. Whatever. Okay. So it seems to be working. I see that isn't M, but it is N. Give it a shot. And then if you type in a Q, it will stop. So go ahead and run it, type it in. Anybody else getting syntax errors? Good? right, so for homework, yeah, let's do a Dropbox. And I guess we're almost out of time for me to give you a homework assignment, but I really want to do that. All right, there's a Dropbox F, so give me your PY file. If you want to upload that flowchart, you can. You would just go back to your drawing program, do download or file, download as, and you can download something, a PDF. Don't got to. Just give me the Python file if you want. So the homework is going to be write pseudocode to ask the user for how many pounds of rice they are going to buy, the price per pound, and then calculate and display the cost. That's pretty generic. It's pretty wide open, right? I'm not telling you variable names and stuff like that, but I will give you a hint that the formula is cost equals pounds times price underscore per pound, like that. That's our formula. Then flowchart with pseudocode. You don't actually have to write this as Python. If you're feeling it, you want to write it in Python, have the satisfaction, go for it. All right. Are we all good?
Does that mean we need to do it on that website and then download it and submit it for homework?
Right, you would draw it on, unless you want to do it by paper or take a picture of it, you can do that as well. But you're right, I could specify where you can draw it. Flowchart it. You can create the flowchart with Lucidchart.
You have to submit the pseudocode and the flowchart?
Yes, please.
Okay. Professor,
Yes, sir.
I haven't had a computer until just recently, so I haven't been able to do any of this on its own.
Just start catching up.
Okay.
All right. And when you upload them, let me know that I said that right. Explain